Hey y'all, welcome back. Today we are reviewing for our Unit 1 test, which is all about linear equations and inequalities. All of the problems on this review will be similar to those that you'll see not only on the test that we're going to take in class, but also very similar to what you might find on the actual TSIA2 exam. So if you're here to study for Mr. Schuler's Unit 1 test, you're in the right place. But if you're also just trying to prepare for the TSI and would like to review the concepts that'll be tested in terms of linear equations and inequalities, then I think you'll find some value in this video. So we're going to go through 25 multiple choice questions that you can expect to see similar variations on your test. So let's start with number 1. It says, what is the value of x in the following equation? X minus 13 equals 5. This is a pretty direct question where we're just trying to solve the equation. Now, with most of these questions, I'm going to show you how to solve these the proper way, but I also want to go through test-taking strategies, ways that you can take advantage of the fact that the test is going to be multiple choice. So like on this one, you should be able to just go ahead and solve it. We would normally add 13 to both sides, which would get us our answer right away, x equals 18. But I also want to show you that you can get this right even if you're not sure what the algebraic steps are. And this is going to be a strategy that you can use on many problems, really any problem where it boils down to solve for x or find the unknown's value. You can just use the answer choices and plug them in one at a time and see which one works. Don't forget that the test is untimed, so you get as much time as you want. So don't hesitate to spend a little time checking all the answer choices. So what I mean by that is, like for this number 1, if I were to plug in 8 and check 8 minus 13, so I'm just plugging in the number into x, 8 minus 13 is negative 5, not positive 5, so that's not going to be right. If I substitute in 14 into x and I do 14 minus 13, that equals 1, and that's not correct either. However, if I try 18 and I do 18 minus 13, I do get that 5, so that's correct. 21 minus 13 is going to be 7. No, that's not going to be 7. It's going to be 8. Either way, that is not going to be our correct answer. So not only do we get 18 the quote-unquote right way, which is this algebra over here, but you can also just check the answer choices and see which one works. And that strategy is one I'm going to encourage. I want you to get as many of these multiple choice questions as you can correct, and that's one way you can just knock out a bunch of them. Number 2, very similar problem. If 5n plus 1 equals 13, what is the value of n? So I'll start by just rewriting the problem over here to give me a little space to actually work this out. And we'll do the same thing on this one that we did on the last one, which is first I will work this out algebraically, and then we'll go back and go over how you might solve it if you forgot the algebra. So we're going to start by subtracting 1 on both sides to get 5n equals 12. And then finally, we need to divide both sides by 5. 12 is not divisible by 5, so we're not really going to get a decimal here. And you can see all the answer choices are in fraction forms anyway. So we get 12 over 5. That's going to be our answer. That's going to be choice C again. So just like with the last one, I am going to go through all these answer choices. And I might not actually compute them all out. I really just want you to know that you can do this strategy. But like if I try to substitute in 5/14, for instance, and I do 5 times 5/14 plus 1. Well, 5 times 5/14 is just going to be a fraction plus 1. There's no way that can equal 13 if I've got that fraction stuck in there. So I'm just going to say this can't equal 13. And I'll do the same thing for each one of these. So 5 times 5/12, so it's going to be 25/12. Again, that's going to be a fraction, so there's no way that's going to equal 13 either. Now 5 times 12 over 5, that is going to equal 12, and 12 plus 1 does equal 13. Now, because you get to use a calculator, make sure that you're using the calculator. You don't need to be like multiplying these fractions in your head or anything. Just type it in so that way you can check real quickly. The last one, you would get a whole number here. 5 times 14/5 is 14, but 14 plus 1 is going to be 15. That's not 13, so that can't work. So yeah, for sure the answer is C. Number 3, we'll work this out just like the previous two. I'll go ahead and rewrite the equation over here. Looks like we have a typo here. The value of n, that should be the value of y. Sorry about that. Let's go ahead and, oh, well, it's going to let me fix it. That's close enough. What's the value of y? So we're solving for y here. 8y minus 5 equals 6. We need to add 5 to both sides of the equation using those properties of quality. 8y equals 11. And finally, we're going to divide both sides by 8. This will turn out like the last problem where we can't actually do the division. You could get a decimal approximation out of the calculator, I suppose, but all the answer choices here are written in fraction form anyway, just like the last one. So we do get 11 over 8. So C. Now you can also check all these answers just like we did the last few. I don't know if it's really worth going through every single one like this, but I guess it couldn't hurt. 8 times 5/8, that's going to be 5, minus 5, that's going to be 0, so that's not going to work. That's not 6. 8 times 8/11 is going to be 64 over 11, so right away, since that's going to be a fraction, there's no way that's going to equal a whole number. 8 times 11 over 8 minus 5, that's going to be 11 minus 5 is for sure 6. So, yep, we kind of already knew that was going to be the answer, but now we're going to have a little bit more confidence there. And then part D, we've got 8 times 8/5. Again, we're going to end up with a fraction here. That's going to be 64 over 5. So there's no way we're going to be able to get that to equal 6. Number 4. Okay, now this equation, there's a lot going on there. Let's just take it one step at a time. We're trying to solve for A. Notice there are some B's in there, but you might notice, well, let's just see what happens. First, I'm going to use the distributive property and distribute this implied -1 to both of these two terms. When you've got a minus on the outside of the set of parentheses, when you use that distributive property, make sure that minus goes to both of those terms. So I'm going to rewrite this equation as 4a plus 2b minus 3 minus 2b minus 6 equals 12 plus a. And now I can start to combine my like terms. And I've got a few here. 2b minus 2b is 0, so those just cancel each other out. We can kind of ignore the two b's now, and that's where all the b's go. And then I'm going to combine minus 3 minus 6 is minus 9. So 4a minus 9 equals 12 plus a. Then to get all the variables on the left-hand side, I'm going to subtract a from both sides, giving me 3a minus 9 equals 12. Then I can add 9 to both sides. 3a equals 21. And then finally divide both sides by 3. So I get a equals 7. So our answer choice here will be B. Now, this one might be a little trickier to test the answer choices with. You still can use that same strategy that we did before. And actually, what might throw you off here is the lack of a B value. But you could just plug in, since we're solving for A, any number you want for B, 0, 1, 2, 3, whatever. And then, as long as you're consistent with that B value, you can plug in the different A choices, 3, 7, 12, and 15, into A and see which one works. I'm not going to go through this one since we already did 3 in a row that were kind of like that. But just please know that is a strategy you can take advantage of, even if you don't have that second variable. Just substitute something else in temporarily and see if you can't figure it out from there. Number 5 says if 5d minus 5 equals 3d, then what's 14d? Okay, so this is not asking for d. We're going to have to solve for d, but then we're going to multiply that by 14. So we'll start with the original equation, 5d minus 5 equals 3d. Then subtract 3d from both sides. We have 2d minus 5 equals 0. Then we need to add 5 to both sides. Now from here, you get 2d equals 5. And what you could do is divide both sides by d here to get 2.5. But I'm actually going to just stop here because we are trying to find 14d. And 14d is 7 times 2d. So because we're not actually trying to find d here, I think the best way to go is to multiply both sides by 7. 2 times 7 is 14, so I get 14d. And 5 times 7 is 35. So 14d is 35. Notice here, once again, we didn't actually solve for d. We're looking for 14d. And we'll approach the next problem in sort of the same way. It says, if 7k minus 2 equals 3k, then what's 22k? We'll start with 7k minus 2 equals 3k. Then, just like the last problem, subtract 3k to bring all those variables over to the left-hand side. Now I've got 4k minus 2 equals 0. Then I can add 2 to both sides. To get 4k equals 2. And here I could divide both sides by 2 or 4, but that is going to give me a fraction. And one thing that's a little different here is that 22 is not divisible by 4. So I think we're probably going to have to go ahead and just find k first. So I am going to divide both sides by 4 to get k equals 1/2. And now that I know k, I can get 22k. I can multiply both sides by 22 to get 22k equals 11. So my answer is C. Now on both of these problems, you want to be a little careful because you can't just go ahead and plug in all the answer choices in the same way that we did all those equations on the first page. Because we are trying to find, like in 514d or 622k, if you try to plug these numbers, like if I try to plug 5, 7, 11, 20 into k, you're going to find that none of those work. So really important that we know that we're trying to get 22k or 14d here. So you just really want to be careful when you're solving this one. I'm not really sure that you can use the answer choices in the same way. You probably can find a way to work these backwards, but honestly, it's probably easiest just to work them out the right way. Number 7 says 8 subtracted from twice an unknown number is equivalent to 16, and we have to write out an equation that correctly represents that statement. So the only tricky part about this one is the subtraction. When I say 8, which is just the number 8, subtracted from, okay, so the subtracted from, we are going to have a minus, but it's going to be from, so minus 8. 8 subtracted from something means that you have something and then you take away 8 from it. So with subtraction, you're always going to do the minus after whatever the next thing is. For example, if this said 8 less than twice an unknown number, it would still be minus 8, even though grammatically you read it as 8 subtracted from or less than. It's just the way that this subtraction gets set up here. You just really want to be careful anytime you're setting up a word problem that has a minus in there. So anyway, 8 subtracted from twice an unknown number. So twice an unknown number, that is 2x. So 2x minus 8. And then is equivalent to, so that's just minus, I'm sorry, that's minus, that's equals. And then 16, of course, is just going to be 16. So that's it. Our answer is A. Get that color coding set up correctly. Okay, so there you go. Number 8 says there are exactly 30 pencils in a pouch. If X pencils are removed, which of the following expressions represents the number of pencils left in the pouch? So we start with 30, and then we take away X pencils, and that's really all there is to it. We're just setting up that expression. So our answer is D. Number 9, again, we are trying to set up an expression from a word problem. We don't have to actually solve anything. We're just doing the setup. It says a bike rental company charges $2 to rent a bike. So that is a one-time fee, plus, okay, so we've got the $2 plus an additional 67 cents per minute that you rent the bike. Okay, so this is not a one-time fee. This is a fee, how do I want to put this? For every minute. Fee for every minute. In other words, we need to multiply that fee by the number of minutes. And it says X is the number of minutes here. That's really all there is. That's it. So the answer here is D. Just want to make sure that the number that has an X on it, you're always going to see, or I shouldn't say always, but quite often you'll see this word per, and that is usually meaning that you're going to multiply by X or whatever the variable happens to be. Okay, if it's per minute, per mile, whatever, that's usually telling you where the independent variable is going to go on. Number 10 says the sum of 3 consecutive integers is 198. A sum is where you are adding up the 3 numbers. Okay, 3 consecutive even integers are going to be x, x plus 2, and x plus 4, where each number is 2 more than the last one. And then the sum is 198. So our answer here is A. There's not really a lot to elaborate on here. Even if it said odd integers, in this case, it couldn't add up to 198 if they were odd, but even if it was like 3 consecutive odd integers, adds up to something that would be, valid. You'd still have the same basic setup here because odd integers are 2 away from each other as well. The consecutive part of it just means they're like right next to each other. So in this case, like 2, 4, 6 would be 3 consecutive even integers. 14, 16, 18 would be another one. So our answer is A. Number 11 says the least of 2 consecutive even integers. So again, we've got this whole consecutive even integers thing. So if P is the smallest one, which of the following represents the sum of the 2 integers? So we're adding them up. So if the first one or the smallest one is P, then the next one needs to be P plus 2. And if we simplify this, we can combine like terms. P plus P is 2P. So we get 2P plus 2. Our answer is D. Number 12 says last year a bakery sold C cupcakes. This year the bakery sold 3 more than twice the number of cupcakes sold last year. If next year the bakery plans on selling twice the number of cupcakes sold this year, how many cupcakes does the bakery expect to sell next year? This one's a little tricky just because you have multiple years where the number is changing. So I think the easiest way to approach this is just 1 year at a time. So let's start with last year. It says last year a bakery sold C cupcakes. So last year was just plain old C. This year, it says they sold 3 more than, so this is going to be plus 3, twice the number of cupcakes they sold last year. That's 2 times C. C is the amount they sold last year. So we should have 3 plus 2C. You could also write this as 2C plus 3, and it would be, a little bit, it would be more in standard form like your answer choices, but this is fine. Next year, it says the bakery plans on selling twice the number of cupcakes they sold this year. So next year they have 2 times everything that they had this year. So 2 times 3 plus 2c. And then we're looking for an expression that is equivalent to next year's number there. So none of these look exactly the same, but we can simplify this using the distributive property. So if I distribute that 2, I'm going to get 6 plus 4c, which is the same thing as 4c plus 6. So our answer is D. Number 13 says the sum of B. Okay, so hold on here. The sum means we're going to add two things together. B is going to be one of the two things. And the product, that means we're going to multiply something 4 times B. So B plus 4B is equals, and then 20. So B plus 4B equals 20. What's the value of B? Well, we just need to solve for B here. 1B plus 4B is 5B. And then we can divide both sides by 5 to get B equals 4. Our answer is C. Number 14 says the profit formula below is for a company's new product, where N is the number of objects sold and P is the profit in dollars. How much profit was made on the sale of 21,000 objects? So the number of objects sold, that's our N. So we're going to replace N with 21,000 and then just simplify the expression for P. Now you get a calculator, so this is definitely a problem that I would recommend using a calculator on. Hopefully your calculator has a little fraction button, but if not, you can just use division for that 3/7. So we've got 3/7 times 21,000, and I'm just typing it over to the side here, just like you would do it on your own, minus 300 is 8,700. There you go. Our answer is A. Number 15 is a little bit different. It looks like it's set up very similarly, but in 15 it says the equation below, T represents the boiling point of water in degrees Fahrenheit, and H represents the height above sea level in feet. If T equals 208 degrees Fahrenheit, what's the value of H? So here we're going to substitute in the 208 for T, and we will have to solve for H. So to do that, we're going to first subtract 212 from both sides. That's going to give me negative 4 equals negative H over 550. And then we can multiply both sides by negative 550 to get our answer for H. So let's see here. Negative 4 times negative 550 is positive 2,200. Didn't we just get an answer that's 2,200 a minute ago? Maybe not. I could have swore I recognized that number from somewhere. That's fine. I must be thinking of something else. C is our answer. Now, this is one that, and just like with the last one too, actually we could have worked, I think the last one's easy enough where you're just typing in a calculator. This one has got a little bit more going on here, but this is a problem where you could use the answer choices to your advantage and just plug all these answer choices into H. Just plug in each one to H and see if I plug all those into H, which of those is going to add up to 208. So like, for example, if I try 650 and I do 212 minus 650 over 550, this is something you'd throw in the calculator. Let's just see what that is just for fun here. That's going to be 210.81. That is not the same as 208. So we know the answer can't be A. And you can test all the answer choices one at a time that way. So just make sure you're aware that that is a legitimate strategy for trying to get some of these right. It won't work for every single problem, but if it does work, you might as well use it. Number 16 says a rectangle of length L and width W has perimeter P equals 2L plus 2W. What is the width of the rectangle in terms of P and L? Okay, so if the perimeter is 2L plus 2W, let's just start with that. Don't even really need to rewrite it because I see the equation up here. We are trying to find the width. So we're trying to find W or isolate W. So to isolate W, we're going to have to move some of these terms around. And I'll start by subtracting 2L from both sides. I'm not actually going to combine anything here because I don't have any like terms. I'm just going to basically be shuffling terms around so that I get the W by itself. So now on the left-hand side, I just have P minus 2L equals 2W. And then if I divide both sides by 2, I'm still not going to get like a numerical answer here. But P over 2 is just P over 2. And then 2L over 2 will be the same thing as 1L. Okay, 2 divided by 2 is 1. So there you go. There's your expression for the width. And it looks like that's answer choice B. Number 17, we've got another solving problem. We're trying to find x. It says if x plus y is 15 and x equals 4y, then what does x equal? So this is actually a system of two equations. We can use the substitution method. Since x is 4y, I'm going to use that and plug that in for x right here. So if I rewrite that first equation, but with that substitution, I have 4y instead of x, plus y equals 15. Then I can combine my like terms. 4y plus 1y is 5y. Then I can divide both sides by 5. And what this is going to give me is 3, but that's the y value. We are interested in the x value. So make sure you take a step back and make sure you don't want to be too quick to say that it's b, because it's not b. Now we're going to go and find x. And you could use either equation to find x. You just need to take that y equals 3 and substitute it into either of the two equations. And I think I'm going to substitute it into this equation where the x is already isolated. That way I don't have to do any algebraic manipulation. So x equals 4 times 3. That's 12. And there you go. We've got our x value. The answer is D. Number 18 says, what are the coordinates of the point of intersection of these two lines? So again, we've got a system of equations, and we just need to set these two equal to each other. I'm going to take this 3x minus 5 and substitute it into y for the other equation. So I've got 3x minus 5 equals x plus 5, and now I can go ahead and start solving for x. Now, because this is a system of equations, we will also have to find y. But notice how all the answer choices have different x's. So as long as we can find x, we're going to be pretty confident that we have our answer. So to solve this, we're going to subtract x from both sides. Get 2x minus 5 equals 5. Then I'm going to add 5 to both sides. So we get 2x equals 10. Divide both sides by 2. And I'll just continue it over here. 10 divided by 2 is 5, so x is 5. So it looks very likely that our answer is going to be C, but let's check for the y coordinate as well. If y is x plus 5, that'd be 5 plus 5, which is 10, which definitely checks out with what we thought it would be. Now, this is a problem which you might not think you're going to be able to use the answer choices, at least at first, because you have coordinates, but you really can. You just need to plug in the first number for x and the second number for y and ensure that both equations check out. So you might, this is going to be a totally different way you could work this. But if we test y equals x plus 5 and y equals 3x minus 5, and if we get two true statements by plugging in the coordinates, we know we have the right answer. So like if we test choice A, for instance, 0, 5. So does 5, I'm plugging that into y, equals 0 plus 5? Well, yeah, that sure works. But if I try that in the second equation, 5 equals 3 times 0 minus 5, that does not work. 5 is not the same as negative 5, so we know it can't be A. And you could test out basically all these choices with the two equations. Just make sure that you're trying them both out, because it's very likely that like one will work, but the other one won't. Like with this next one, 8 is 3 plus 5. That checks out. But 8 does not equal 3 times 3 minus 5. 9 minus 5 is 4, so that doesn't work. So we know it can't be B. With C, we're already pretty sure that's going to be our answer. but just to check that one more time, 10 does equal 5 plus 5, so that checks out. And 10 is equal to 3 times 5 minus 5. 15 minus 5 is 10. So yeah, C is definitely going to be our answer. And you can test the last one as well. 15 is 10 plus 5. Yeah, but 15 is not 3 times 10 minus 5. 30 minus 5 would be 25, not 15. So you can see that, even if you're not sure how to work this problem out algebraically, as long as you know that you can use the answer choices to your advantage, you can still get a bunch of these right. Okay, let's go on to 19. It says Jack bought 4 books. Cam bought 5 books in a $16 binder. Together, they spent $43. If each book cost the same amount, how much did each book cost? So we're going to set up an equation here. This one's only going to require one equation. We've got 4 books, and let B be the cost per book. Okay, and the reason why I'm letting that mean my variable is because that's what the question's asking for. How much did each book cost? So I want to make sure my variable stands for that. That way when I solve it, I have my answer. So 4 books plus an extra 5 books from Cam and that one $16 binder, and there's just one of those, so I don't need to multiply it by a variable, equals $43. And here we just need to solve the equation for B, which is the cost of the book, or cost of a single book. When I combine my like terms, I'm going to get 9b plus 16 equals 43. Then I can subtract 16 on both sides to get 9b equals, and this is, definitely a case where you want to use a calculator to make sure you're getting the arithmetic right. I'm getting 27. Then I want to divide both sides by 9. That'll give me b equals 3. So our answer is C. You could check the answer choices on this one too. You just have to make sure that you're setting it up correctly. Like if I'm testing the first number, $2, you're going to do 4 times 2 plus 5 times 2 plus 16. If that doesn't equal $43, you know the answer is not that one, which it is not. But you could also go through all the answer choices and find the answer that way. I really want to encourage you to use that strategy too, because if you can get a few extra questions right by using that strategy, then we'll call it a win. Number 20 says Mark bought 7 sandwiches from a deli. Must be a hungry guy. Some of the sandwiches cost $3 and the rest cost $4. If he paid a total of $23 for all the sandwiches, how many of the $3 sandwiches did he buy? So there's really 2 variables here. It seems like there might just be one, but the 2 are for the 2 different costing sandwiches. So how about we let X be the number of $3 sandwiches, and we'll let Y be the number of $4 sandwiches. And, when you're solving a system, usually you're trying to find both variables, but this particular question is only asking for the number of, how many of the $3 sandwiches. So we're really just looking for this X. Okay, so if we can solve for X, we don't really need the Y. It might be helpful to check and make sure we got the right answer, but it's not going to be totally necessary to get this question right. So we should have 2 equations here. One is going to be set up for how many total sandwiches there are, which there are 7. So the number of $3 sandwiches plus the number of $4 sandwiches would be 7. There's a total of 7 sandwiches. And then the second equation that we'll need for our system has to do with how much everything costs. So the X sandwiches cost $3, the Y sandwiches cost $4, and altogether cost $23. So we've got our system. We're getting ready to solve it. We're going to use substitution. You can use elimination here, but we've kind of focused on substitution. So I'm going to stick with that. And I'm going to try to substitute the first equation into the second. And you have a little bit of freedom here on how you're going to do that. We could isolate either X or Y. But since we're trying to solve for x, right, that's really what we want, let's try to get rid of the y. In other words, let's isolate y in the first equation so that when we make the substitution, we could just solve for x directly. So I'm going to rewrite this top equation. If I subtract x on both sides, I'm going to get y equals 7 minus x. And that expression is what I can use to substitute into y for the second equation. And when I make that substitution, I'll only have x's left over, so I can just solve for x. Okay, so let's write the equation that we're actually going to solve here. With that substitution, we have 3x plus 4 times 7 minus x equals 23. Now at this point, once you get your equation set up, you can just test each answer choice to see which one works. I definitely want to encourage you to do that. I'm going to work this out traditionally, though. I'm going to start with the distributive property. That'll give me 3x plus 28 minus 4x equals 23. Then I can combine like terms. 3x minus 4x is negative 1x. So I have negative x plus 28 equals 23. Then I can subtract 28 from both sides. I'm running out of room here, so I'm going to continue this up here. So negative x equals negative 5. And then if I divide both sides by negative 1, I get x equals 5. So there are a total of 5 $3 sandwiches. Now, if there's a total of 7 sandwiches, you kind of get the y value for free here. If we know that there's 5 of the $3 sandwiches, there's 5 of these. That's a 5, not an S, by the way. That means there's got to be 2 of these, right? Because there's a total of 7. It doesn't ask for that, but just sort of FYI there. Okay, number 21, we're moving on to inequalities. So it says which inequality can be used to represent the solutions given by the number line graph. And this is going to be pretty straightforward. There's nothing to solve here. You see the arrow going to the right. That means our solution set will contain numbers that are bigger than negative 3. So that's going to narrow us down to A and C. And so the question becomes, do we want the little line underneath the greater than symbol? And here the answer is no. When you have this open circle, that means you do not want to include that value in your solution set. Okay, so an open circle you'll use with either like less than or greater than strictly. A closed circle means you do want to include that point in your solution set. So it would be greater than or equal to, less than or equal to. Basically, you'll have the equal to. So because it's an open circle, it's going to be one of these two. Since it's pointing to the right, right, you're going to use this one. So the answer is A. Number 22 says which inequality represents the situation the temperature should be at most 80 degrees. Well, if it's at most 80 degrees, it could be less than 80 degrees. It could be 80 degrees. It just can't be more because it is at most 80 degrees. So the inequality symbol that you want to associate with this little phrase here, at most, is less than or equal to. So the temperature should be at most 80 degrees. So our answer is C. For number 23, we're just solving for x. And when you solve an inequality, you want to take the same basic steps that you would for equations. The only catch here is if you have to multiply or divide both sides by a negative number, you do need to flip that sign. So we can add 5 to both sides here, no problem, to get negative 2x is greater than negative 4. But then when we go to divide both sides by negative 2, that's where you want to be extra careful here. Because an inequality is going to have to flip the sign anytime you divide by a negative. Okay, so divide by a negative. You got to flip the inequality symbol. Flip the inequality symbol. That is not how you spell symbol. There we go, symbol. Okay, so the greater than is going to become a less than, and we're going to get x is less than negative 4 divided by negative 2 is positive 2. So our answer is A. Okay, those are all the ones that cover the material we've talked about so far. We've got two last problems here, and I gave you a little hint here that these might require steps that we haven't used yet. Now, I don't want to go through the algebra and how I would solve these sort of the right way, because what I really want to emphasize here is no matter how complex your equation is, if the problem just boils down to solve for x, then you can use the answer choices to get these questions right. So like the first one has a square root on it. We have not solved any with square roots. And honestly, it's not even that hard. You probably could figure out how to solve this one. But I just want to emphasize this test-taking strategy of plugging in the answer choices to try to get the right answer. So for number 24 and 25, that's all we're going to do. I'm not going to go through sort of the proper way to solve these. I'm just going to sort of well, I don't want to call it like a cheat way, but you're using your resources wisely here. It's one way to put it. So let's plug in 253 and see what happens. So if I plug in 253 plus 3, I'm just going to put that directly into my calculator. I'm not going to think about it too hard. I'm just testing to see, does that equal 12 or not? And so 253 plus 3 is 256. The square root of 256 is 16. That is not 12, so it can't be A. When I try 141, 141 plus 3 is 144, and the square root of 144 is 12. So it looks like our answer is B, but I think it's worth checking out the rest just to make sure we did it right. Okay, the square root of 81 plus 3. Now, 81 plus 3 is 84. And that's not a perfect square. So if you can recognize that, you know this can't be the right answer. It is approximately 9 point, looks, if I round that next decimal, 9.2. It's approximately 9.2. Either way, it's not 12, so it can't be C. We already know the answer is B, so it's not going to be D, but you could check this all the same. Find the square root of 12, and that's about 3.5. Okay, again, not 12. So this is, I just want you to, have this strategy as like a tool in your back pocket to you use it whenever you can, especially when the equations start to become a little bit more complicated. Like 25, this is technically a linear equation, but it's got a bunch of fractions in there. And I think this is, just like 24, going to be a lot easier to just reverse engineer the problem and work backwards from the answer choices. So let's start with A. If I substitute negative 16 in, I have negative 16 over 8 minus negative 16 over 4. And I want to know, does that equal 2? Well, negative 16 over 8, that's negative 2. 16 over 4 is 4. I'm subtracting a negative, so that's going to be plus 4. And that actually does equal 2. So it looks like our answer is going to be A. But let's check the rest of them. Negative 8 over 8 minus negative 8 over 4 would be negative 1 plus 2. All right, that's just 1. That is not the same as 2, so it can't be B. For choice, I circled B. No, it can't be B. For choice C, we've got 4/8 minus 4/4. That is going to be a half minus 1. Clearly, that can't be right because that's just a half. That is not the same as 2, so it can't be C. And we could test 16, even though we're pretty sure that's not going to be right. 16 over 8 minus 16 over 4 is 2 minus 4, which is negative 2. So close, but still not 2. So it's not going to be that one either. So we can rest assured that the answer is A. Now I'm going to give you on the test a couple of questions like this that is going to require algebra that maybe we didn't really practice in class. But on these problems, what I'm looking for you to do is to test out those answer choices. And I want you to use that strategy as much as you can, just because you will be way more likely to get the right answer if you do. So anyway, that is it for today. As always, if you have any questions, please come see me for tutoring. Shoot me an email, comment on this video. Just find a way to reach out to me, and I will make sure to try to get back to you. Thanks for watching. Y'all have a great day.